Hello students, welcome to online classes of Sri Mahavir International School. So in last video we discussed about the metals and non-metals and the reactions with the different things like the water and oxygen. So today we see that some metals like the sodium and potassium react vigorously with the dilute acid. Here some equations by which you can understand. Here the sodium is reacting with hydrochloric acid and forming the sodium chloride, and the hydrogen gas will be left, and the magnesium reacting with hydrochloric acid, and then that magnesium chloride and the hydrogen gas. So metals like zinc and iron show the moderate reactivity with the acid, while tin and lead react very slowly. Metals like silver, gold, copper, platinum and do not react even with dilute acid. After then we see the activity number 8. To observe the reaction of metal zinc granules with acid to be demonstrated by the teacher. So take a 5 ml of dilute hydrochloric acid in a test tube and put a zinc granule into it gently. You will see the bubbles being the formed in the test tube. Bring a burning matchstick near the mouth of the test tube and the burning matchstick goes off with a pop sound and showing that the gas evolved is hydrogen. So this pop sound generated because of the presence hydrogen gas. Now the zinc react with the hydrochloric acid and the forming the zinc chloride. Now the oxygen hydrogen gas will be erupt. Now the action of bases with metals. How the most metals do not react with bases. Lead, aluminium and zinc are metals that react with strong bases like the sodium hydroxide and potassium hydroxide to form the complex compounds with the evolution of hydrogen gas. Zinc react with the sodium hydroxide, and if you heat then that will form the sodium zincate and hydrogen gas. Zinc react with the sodium hydroxide and forming the sodium zincate. Now the displacement reaction. So students, in the displacement reaction we see that more reactive metal will displace the less reactive metal. This is the table, okay, in which we see the reactivity of metals, that higher reactive, that is potassium, and just below sodium, then barium, and the calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, silver, gold, and the platinum. Now the displacement reaction. We have seen that metals react with air and water at different rates. Depending on these rates, we can arrange the metals in an order such that the most reactive metals is placed on the top of the series, and the least reactive metals is placed at the bottom of the series, and this series is termed as reactivity series of metals as shown alongside. The metals at the top in this series can displace a less reactive metals from its salt, and a less reactive metals cannot displace the more reactive metals from the salt, and a reaction in which a more reactive metals displace a less reactive metals is salt is called the displacement reaction. So overall students, as I told you that more reactive metal will displace the less reactive metal. When some zinc granules are put in beaker containing blue colored copper sulfate solution and zinc which is more reactive, then the copper displaces the copper from copper sulfate and the solution in the container become colorized and due to the formation of zinc sulfate. Here the zinc which reacting with the copper sulfate, okay, and here that is zinc that is more reactive, okay, that displays the copper, okay. So in this the copper sulfate, here is a zinc sulfate. Then what happened, that zinc which was higher reactive, it displaced the copper, okay. Now copper is out. Another example of displacement reaction is when zinc react with the dilute hydrochloric acid but silver and gold do not react. So this is because silver, gold and copper are less reactive than hydrogen. Now the activity number 9. So to observe the different displacement reaction, take 5 beakers with 1/4 water in each, label them as the 1, 2, 3, 4 and 5, dissolve 2 gram of each of the substances given below and stir the contents in each beaker and iron nails copper sulfate and beaker iron nails zinc sulfate, third beaker copper turning plus iron sulfate, and fourth one copper turnings magnesium sulfate, and in 5 beaker zinc granules with the copper sulfate. Then here also you will see a displacement reaction. You will observe that a red powdery mass of copper settle at the bottom in the beaker. Then so students, you will observe that a red powdery mass of copper settle at the bottom in beaker first, and the fifth with the formation of the iron sulfate and zinc sulfate respectively, and the blue color of copper sulfate displayed disappear in the both of the beakers. You will observe no change in the beaker 2, 3 and 4. It is clear from this activity that more reactive zinc and iron displace less reactive copper from its salt. Now students, chemical properties of non-metals. Action of oxygen on non-metals. So non-metals react with oxygen to form the non-metallic oxide. Non-metal react with oxygen and forming non-metallic oxide. Here the non-metals generally do not react with oxygen in the air at room temperature. The oxides formed by the non-metals are acidic and neutral in nature. The carbon react with oxygen and form the carbon dioxide. So the white phosphorus is an exception. It repeatedly burns in the air at room temperature to form its oxide. It is thus the stored in water. Phosphorus react with oxygen and form the phosphorus pentoxide. Now the activity number 10 C, to observe the action of oxygen on sulfur. Take some sulfur powder in a flagrating spoon, heat it over a burner. When the sulfur starts burning, put the spoon in a glass and cover it with a lid. And the caution is what? Do not expose yourself to the fumes as they are toxic. Sulfur react with oxygen and form the sulfur dioxide. Put some water in the glass jar and shake it well. The sulfur dioxide dissolve in water to form the sulfurous acid, and the sulfur dioxide react with water then making and forming the sulfurous acid. Take some sulfurous acid in a dish and put a blue litmus paper into it, it changes to red, showing the acidic nature of the solution. So see here, this is the burning of sulfur in oxygen. So all the reaction as you see in this picture also. Now the action of water on non-metals. Water on non-metals. Most non-metals do not react with water, but some non-metals like the oxygen and chlorine dissolve in water. Oxygen dissolved in water is used by the aquatic plants and animals for respiration, and the chlorine dissolved in water to form an acidic solution. When this solution is heated, it forms the hydrochloric acid and oxygen. Reaction with acid and bases. Non-metals do not react with acid and bases at room temperature. So students, here some properties regarding the metal and non-metals. See, reaction with oxygen. If a metal react with oxygen, then it will form the metallic oxide. And what about the non-metals? It will form the non-metallic oxide. And nature of oxide form, that is basic in metal, and in non-metal, nature of oxide, that is mostly acidic and neutral. And the property of reaction with water, form the metal oxide or hydroxide and hydrogen gas. And non-metals means no reaction with water under normal condition. The reaction with acid form the metal salt and hydrogen and do not react with acid. Next thing is students, as we see, true false. The metals react with oxygen to form the metallic oxide, and magnesium aluminum react with oxygen. So after reading this chapter, students, you are able to answer in true or false. So fill your answer with the help of pencil. Now the usage of metals and non-metals. Students, in our daily life there are uses of metals and non-metals. So let's see. Some uses of metals are as follow. So metals like the copper and aluminum are used to make the electrical wires to conduct electricity. Utensils, tools and machines are made of copper, iron and aluminum. Aluminum is used to make foil, which is used for wrapping food. Iron is used for the construction of buildings and bridges. Gold, silver, platinum are used for making the jewelry, ornaments. Magnesium is used in the fireworks as it burns with the dazzling white light. And tin is used to make the cooking utensils and the electrical fuse wires. Mercury is used in thermometers and the CFLs, and the sodium, titanium and the zirconium are used in space research, and the lead is used for making the X-ray shield and bullets. So students, these are what? These are the uses which we see face in our daily life. So here students, the use of mercury which in thermometer, because that it remains in liquid state at the room temperature. And some interesting here like the gold and the silver and platinum which are used in for making the jewelries. And one more thing, that the aluminum is used to make the foil, okay, which is used for the wrapping food. So therefore students, and utensils, stools and the machines are made up of copper, iron and the aluminum. Because the utensils, if you are making the utensils of metals, then heat can be conduct by that metals, so food can cook very easily by using the utensils which is made up of what? Metals. So students, in next class we will discuss the some uses of non-metals. Okay.